The Messages API is the core endpoint for talking to Claude programmatically, and understanding every field here pays off later, since tool use, vision, and MCP all extend this same basic shape. A minimal request has 4 key fields. Model is the version model string. Max tokens is the maximum number of output tokens Claude may generate, required on every request, and a ceiling, not a target, since Claude may stop earlier. System is a top-level field, separate from messages, for standing instructions like persona and output format. Keeping it separate lets you reuse it across conversations and is what prompt caching typically targets first. And messages is an array of turns, each with a role and content, representing the conversation history. The API is stateless. Claude does not remember previous calls on its own. To continue a conversation, you send the entire message history back on every request, appending the previous assistant response and the new user turn yourself. This has direct cost and context window consequences. A long conversation means resending and being billed for the whole history as input tokens on every turn. A response includes content, a list of content blocks, usually one text block for a simple reply, with more blocks appearing for tool use. It includes stop_reason. In_turn means Claude finished naturally. Max_tokens means the response was cut off by your ceiling. Tool_use means Claude wants to call a tool. And stop_sequence means a custom stop string was hit. And usage gives input and output token counts, which is what you'd log for cost tracking. Always check stop_reason in production code. Silently accepting a max_tokens truncated response as complete is a common, avoidable bug. Put stable, task-defining instructions, role, rules, output format, in system, and put the actual conversational content in messages. Mixing these, like restating the persona inside every user message, wastes tokens and makes the prompt harder to maintain. This distinction matters more for programmatic use than casual chat, because you're often generating messages content dynamically from application data. For latency-sensitive applications, chat UIs, anything where a user is watching, use streaming instead of waiting for the full response. Streaming sends the response incrementally as server-sent events, letting your UI render tokens as they're generated rather than showing a long blank pause. You still get a final assembled message object with full usage and stop_reason once the stream completes. Streaming changes delivery, not the underlying content. Temperature, from 0 to 1, controls randomness. Lower values produce more focused, deterministic output. Higher values produce more varied, creative output. For classification, extraction, or anything with a correct answer, use low temperature, often 0. For brainstorming or creative writing, higher values are reasonable. Top_P and top_K offer alternative control over sampling diversity, but most applications only need to tune temperature. Importantly, these parameters affect variety, not factual accuracy. Lowering temperature reduces randomness and phrasing. It does not reduce hallucination risk on its own. Modify the request example to run as a true multi-turn conversation. Make 3 sequential API calls, each appending the prior assistant response and a new user message, and print the growing token usage after each call to see context accumulate. To recap, the Messages API takes a model, a required max_tokens, a top-level system field, and a messages array. The API is stateless. You resend the full history yourself on every call. Always check stop_reason, since max_tokens truncation is a common silent bug. Streaming delivers output incrementally for latency-sensitive UIs. but still resolves to a full final message. And temperature controls output variety, not factual accuracy. Use low values for deterministic tasks, higher for creative ones.